Requesting everyone to be seated. We are beginning with the deliberations of our second day for our International Galvanizing Conference. Once again, requesting everyone to come forward. Kindly be seated. As you all know that yesterday we began with the inaugural session, and what a remarkable session that was. We had the presence of the Hon'ble Minister for Steel, Petroleum and Natural Gas. We had the presence of Hon'ble Minister of State for Steel, and alongside that there was great understanding and way out for the zinc industry by and large. Followed by that, the day witnessed lots of interesting deliberative session, and it was concluded with a very remarkable networking reception and cocktail dinner last night. Today, as we commence the agenda for our day 2 of the International Galvanizing Conference, we'd like to once again welcome everyone, welcome each and all, and we'd like to also tell you that as the deliberations and paper presentations come forward during this day, during the end of the day today, yes, we have some exciting prizes lined up for all the people present with us, and these prizes would be given in person. So yes, some exciting giveaways, but that has to be received in person. So we look forward to your support, we look forward to your cooperation all throughout the day, the final day of our 2-day-long International Galvanizing Conference. And now to set the tenor, once again, good morning to each and all. Welcome once again to the 3rd International Galvanizing Conference 2019. Before we commence, we're all, for all the esteemed audience present with us, please keep the mobiles and communication devices on the silent mode during all times of our panel discussions and sessions. As you all know that yesterday, on the day 1 of our 3rd International Galvanizing Conference, we had a number of interesting sessions about the galvanizing opportunities in the Indian market. We deliberated upon how galvanizing plays an important role in building up the key structure and infrastructure for national and other importance. We also had 2 amazing panel discussions where eminent players from the industry, media got together to discuss the increase in role of galvanized steel in the development of our economy, and the panels and the panelists also looked into measures to increase the use of the same. Once again, our industry leaders also shared their immense experience, expertise and knowledge for the global best practices that can be employed, and at the same time looking forward to opportunities for their potential adoption in the Indian scenario. Once again, welcome everyone after this great day yesterday that we had, the day 1 of our 3rd International Galvanizing Conference. Now to set the context and update us more on what can be more takeaways from our yesterday's deliberations and what lies ahead for our second day today, I invite on Dr. Rahul Sharma, Director, India Chapter, International Zinc Association. Dr. Rahul Sharma, once again, welcome. Good morning, sir. With a round of applause, let's welcome Rahul, sir. And sir, we look forward to guidance from your side to set the context of our day 2. Sir, please.
Thank you, Amna. Good morning, ladies and gentlemen. So I have started my day reading newspaper, and that's wonderful news. Our conference has been covered in 26 leading newspapers of India. So that includes Times of India, Economic Times, all newspapers, right? So 26 newspapers. So that's a good news. Now I'll give you a recap about the yesterday's activities. So I would like to welcome you once again on day 2 of the International Galvanizing Conference. So we are delighted to have you with us to participate and share, in our IGC. So thank you all for coming. This year, the theme of our conference was Galvanize India, it works. And definitely, yesterday, we saw that all the prominent speakers, they emphasized on the need of more galvanization. Also, we saw many dignitaries speaking on the importance of galvanization. Our chief guest, Union Minister for Petroleum, Natural Gas and Steel, He spoke about how galvanization of steel can help in achieving sustainability. He also said that galvanized steel is poor man's stainless steel. So that's a good remark. And I really appreciate the wordings of Honorable Minister. Then we had a galaxy of noted speakers. They presented an overview of steel and zinc industry. Also, we saw users department experience of using galvanized steel, and they also talked about the future potential applications. Further, experts also spoke about the importance of a standard and quality control order in India. So today we will again have some exciting presentations on automobile sector, construction and infrastructure sector. So I will not take much time. I would like you to welcome once again on day 2 of the International Galvanizing Conference. So happy learning and have a good day. Thank you.
Thank you, Rahul sir, for that update. So yes, right from being covered by several national and international forums for our deliberations, and of course looking into new insights, our third International Galvanizing Conference has lots for everyone. Once again, as we begin with the deliberation, we'd like to tell you that we request all our participants, all our distinguished delegates to be there with us all throughout the day. And as we once we conclude the day, we have some exciting takeaways for all of us. So please be there with us. And at the start, let's take the deliberation forward with Dr. Andrew Green, who will be joining us to deliberate on the zinc market potential and global application. Dear distinguished esteemed audience, Dr. Andrew Green definitely needs no introduction amongst all of us. He is the Executive Director of International Zinc Association, and he manages day-to-day activities of our IZA with the aim of providing significant and sustained value to the member companies. So with a round of applause, let's welcome Dr. Andrew Green. Dr. Green, a very good morning, and we look forward to learning with you. Everyone, zordar taaliyon ke saath. Let's welcome Dr. Green. And we'd like to share with all the members present with us in the house that yesterday we had such a power-packed agenda. That's why we had to reschedule some of the presentations. Dr. Green had to address yesterday, but looking at the fact that we had a media one-on-one that happened right after the inaugural session, alongside that managing other aspects of our panel discussions for yesterday, this is why we have to shift the presentation by Dr. Andrew Green to today. So once again, welcoming Dr. Andrew Green. Dr. Green, please.
Namaskar. Let's try that one more time. Namaskar. Namaste. I am very pleased to be with you here today. I have come to India probably 12 times. And it's always a pleasure for me. I love the culture. I love the activities that we have going on in India, thanks to Rahul and Sumitra and the rest of our IZA team. I also love the food, so it gives me great pleasure to come here. But also, I've created many friends, many contacts in India over these past many years, and I look forward to creating more friends as we go forward. So with my presentation this morning, what I'm going to try and do is just give you a brief overview on key global applications for zinc, key markets that we are working to develop through our market development activities. And I'll note, as the organizer was mentioning, that this presentation was originally scheduled for yesterday, so some of the things I'll be highlighting have already been touched upon in some of the presentations yesterday. Others will be highlighted with more information later today. This is the International Zinc Association's mission statement. I'm not going to read it to you. I'll let you read it while I talk. But what I want to get across to you is that our organization, the International Zinc Association, represents the voice of the global zinc industry, the champion for the zinc industry, if you will. So we represent companies such as Hindustan Zinc around the world, identifying key markets to help develop, to help protect, to make sure that we have license to operate. And we do this in a number of different activities, as I'll touch upon. These are our core programs. So you can see here technology market development, which is really the focus of the conference here in India. We also have our environment, health, and sustainability activities. And this is more on the market to ensure that we protect and ensure license to operate amongst all of our companies. And then communications. The conference itself is a great example of our communication activities, brochures, videos, podcasts, those types of things, which I'll be touching upon later. And throughout all this, as you can see from the graphic here, sustainability plays a key role. And that's been touched upon, I think, in some of the presentations yesterday. I think it'll be touched upon later today, but that's a key message about the benefits of using zinc for these applications, whether it's the automotive market, the infrastructure market, what have you. Protecting steel from corrosion, it speaks to the very essence of sustainability and ensures long life, it ensures efficiency, it ensures safety. All these things tie in together from a sustainability standpoint and helps to make sure that the steel lasts longer, doesn't have to be replaced as often, and that reduces the carbon footprint for zinc, for steel, reduces the cost to society and so forth. So as we've heard, I think as all of us know, the zinc market is very much linked to the steel market. And I just wanted to lay out a couple points. Some of these have been addressed by some of the other speakers, but I think if you have a good message to tell, you should say it often, you should say it loudly. So I'm going to say it a couple more times here today. So if we look at the global steel market, approximately 7 billion tons of zinc or of steel are produced annually. And this comes from World Steel and from some other groups. And yet only about 6%, maybe as much as 7% of that 1.7 billion tons of steel is actually protected with zinc. That right there, without going further, represents a tremendous opportunity for zinc. We just need to change 1% increase of that steel coverage, and it will have a tremendous impact in terms of sustainability, in terms of the zinc market, and in terms of the benefits to society. Now, again, if you look at the zinc market separate from this, about 60% of the 13 million tons of zinc produced annually goes towards the protection of steel. So of that 6% that is being used for steel, that represents about just under 8 million tons of the total zinc market is going towards corrosion protection. So it's a tremendous segment of the overall usage of zinc. We can't say that enough. Galvanized steel is the main market for zinc now and going forward. And then we've heard these numbers before, and I know my associate Ken has done some work to update this. Globally, around 3 to 4% GDP is lost from the steel not being protected properly with zinc. That number right there should be a shock to anyone that hasn't heard that before. Countries try and achieve increases in the GDP of 1 or 2%, and they'll undertake all kinds of economic incentives and other activities to do this. And yet here we have a simple solution of galvanizing that steel and increasing the GDP as much as 3 to 4%, and as you'll hear later on, this could be even higher than 4% here in India. So when you tie these things together, I think, again, the point I'm trying to make here, and as you've heard from other speakers, is that there's a tremendous opportunity. We only are currently protecting about 6% of the total steel produced. That means there's about 94% of those 1.7 billion tons of steel produced annually that still needs the protection for zinc. So if we can just change, again, 1 or 2% with the incentives, the activities that we're doing on the automotive sector, in the construction sector, in the railway sector, what have you, this could be a very significant impact, a story-changing type impact in terms of the overall zinc market. So I'm just going to touch on a few of these markets. You've heard about some of these a little bit before, and you'll hear about others a little bit later. But thermal spray is one of the key initiatives the International Zinc Association has been working on this past year and going forward. This started off with offshore power, offshore windmills, where we were able to get the specification from Siemens to ensure that zinc and galvanized steel is used for this protection. And since then, we've seen the opportunity to expand this even further into ships, bridges, as well as railways. And we heard yesterday a lot more information about the possibilities for zinc protecting the railways in India. We see this as a great opportunity, something that's happening right now thanks to the efforts of Rahul and others here in India. These are the types of initiatives that we see going forward. And the news is getting out there. This is just a snapshot. Each one of these panels represents information that's gone out into the media in different settings, whether it's shipping news or what have you, highlighting the benefits of galvanizing steel, using thermal spray in the shipping, bridges, and so forth. So again, I think it's a key new initiative that's already having success here in India, and we hope to expand this further globally. Automotive market, obviously a very key one for zinc, also key for the steel industry. Frank Goodwin, Dr. Frank Goodwin, our associate, leads this effort with the Galvanized Auto Body Program. I think many of you know the great work that Frank has done over the years. And this is a collaborative effort. That's really the way that IZA operates best. What we bring to our zinc members, such as Hindustan Zinc and others, is leveraging resources. We leverage the resources of the zinc industry to achieve these programs collectively. And then we try and leverage that resource even further by developing partners. So in this case, if you look at the automotive sector, these are the partners that we're working with to leverage the resources, leverage the impact that we can have collectively working together. And you can see here, these are some of the major players from the steel industry, such as Tata Steel and others here in India, as well as the automotive sector, working together to develop the next generation of high-strength, lightweight, galvanized steel to go into these automotive sector. And that plays a key difference going forward. If you look at some of the markets that are developing now within these cars, the lightweighting effort for electric vehicles and so forth, galvanized steel has a number of advantages over other materials such as aluminum and so forth. And the nice thing for zinc is, and galvanized steel for that matter, we have future generations of these alloys coming thanks to the work of the automotive program with the Galvanized Auto Body Partnership. This is an area where the research is already paying dividends and will pay dividends in the future by creating these new alloys that will continue to increase the lightweighting, increase the strength, and improve the corrosion protection with zinc. This is a table I found very interesting, and it ties to some of the information we heard yesterday from Sunil Dugal and others, talking about the tremendous opportunity we have here in India with the automotive market. So you can see the penetration in terms of galvanized steel being used in the automotive sector in these different countries. Here in India, the estimate from this study is that only around 15 to 20%, we think it's around 17% right now here in India, is actually using the protection of the galvanized steel. Whereas we know that automakers here in India exporting those cars are galvanizing 100% of those cars. That's a big problem. I think if the public here in India understands the protection, the benefits that comes with galvanized steel for the automotive, knowing that these car companies are producing cars like this and exporting it to the rest of the world, but domestically they're producing just 17% of those cars with this galvanized protection, I think it begs the question why this is happening. This represents the state-of-the-art protection for the car. It ensures better strength, better long-term protection for the consumer. And I think it's something that the people of India should be demanding from the car makers here, is that they actually galvanize the cars. I think this is a key area for promotion and awareness activity here in India. Just to touch on a couple other areas of corrosion protection that the IZA is working on. Again, this is another example partnership. We're working with galvanizer associations, we're working with steel associations to promote the use of steel utility poles. And this is to replace concrete or wood utility poles that don't have the same benefits, the same cost benefits and longevity in terms of life cycle costing of the galvanized steel. I realize you may not be able to read these, but you'll just have to take my word and look at the fine print later. But each one of these represents a grid system, an electric power system in the United States, where the key decision maker has recognized the benefits of switching from wooden poles or concrete to galvanized steel. And in most of these cases, these quotes are basically noting that because of the severe storms, hurricanes, what have you, that have come through, where the wooden poles get snapped, but the galvanized steel poles remain, they recognize this as a long-term investment that will benefit the society, reduce the cost in the long run, and ensure the power supply to the individuals. So I think this is something that we need to push, not just in North America, but also globally. This is one of my favorite new areas that IZA is working in with the zinc air batteries, and it's something we've been following for 20 years. But the reality is that the chemistry, the technology in this area has developed significantly in the past year or 2 years with companies such as NANT Energy and EOS, to where you can see the first bullet there highlights that NANT Energy has now developed a battery that has broken the price barrier of $100 per kilowatt hour. This is one of those target price barriers that has been set in the industry, recognizing if you can have a battery that achieves that, you can really make a difference in terms of the market impact. So that's been done. We have a survey going on right now, an assessment of the overall market, and we see this really as fitting very nicely with the storage system. Perhaps not competing against others with the car batteries themselves, but the zinc air battery chemistry works beautifully with the storage system. So providing storage power from things like solar panels, windmills, backup generation, that type of thing. There really is, I think, a tremendous opportunity for us here. The graph on the left depicts why this is such an important thing. And if you look at this graph, what it basically tells you is that between 2015 and 2025, in 10 years, the expectation is that the electric storage system market will double in size. Again, this represents a large opportunity for the zinc battery to make a penetration and impact in that particular market segment. And if you look at the graphics to the right of that, you can see already where zinc air batteries have already made a difference. So providing a source of power to over 200,000 people, eliminating the need for 4 million liters of diesel fuel. These are just a few examples, and we're just having a small penetration right now. You can just imagine what these numbers, these metrics might be like once we have a much greater penetration into this market. And this ties into the whole solar panel market as well. Solar panel and solar energy is the fastest growing power production in the world. You can see again the graph at the bottom showing the marked increase in this. And what this represents for zinc is twofold in terms of market applications. One is galvanized steel for the structure, for the framing of these solar panels. And two is, again, the storage system that I was talking about before with batteries. As these solar panels get wider used, as the market increases in this area, that will have an impact for zinc in two areas. One is the galvanized steel, and one is the zinc batteries. And I can speak from experience in this particular case because I added solar panels to my house just last year, recognizing the long-term benefits of using this. So I have galvanized steel on my roof as a result. And as soon as the zinc air battery comes out for domestic use, I will be one of the first people purchasing this. Galvanized rebar is another area that we have touched on in the last couple presentations from yesterday, and I think we'll have a much greater focus on it this afternoon. But again, if you go back to my first slide talking about the penetration, the impact of zinc with steel, where only about 6% of the 1.7 billion tons of steel is actually protected with zinc now. Rebar represents one of the biggest, if not the biggest segment of that steel production. So we have another large opportunity here, and one of the new technologies come out recently, thanks to some of the efforts of the International Zinc Association, is using the continuous galvanized rebar. So you run a production of the rebar continuously through the bath, and what this does is impact the benefits in many ways. One is it reduces the costs. Two is it allows bendability, so you can go ahead and make the bends and the shapes that you need in advance to taking it out to the site, rather than shipping the rebar out there, bending it, sending it back to the galvanizer to be protected, and then sending it back to the site. So you can just imagine the transportation cost that saves. When you take all that together, the continuous galvanized rebar represents I think a very good opportunity, one that we see expanding in places like the US and China, and we understand that a continuous galvanized rebar line is going to be added here in India in the near future. I think once that happens, you'll see the landscape changing. When people see the success you can have, the cost benefits of using galvanized rebar here in India, other people will quickly take this up and move it forward. So I think, again, it's an issue of awareness and promotion, but once we get that first line operating, we'll see a difference here. Architectural zinc sheet. This is a major segment here, not here in India, but in Europe, but it's one where we see it being applied for architectural settings in North America and other places. IZA is working to help promote this market through activities on life cycle costing and so forth. We have a number of buildings around the world, and if you go to Paris, for example, almost all the roofing in Paris is zinc sheet. It's absolutely stunning, and I think when you see these buildings, you recognize why zinc sheet should be used more for wall facades, for the roofing and so forth. And it's something I hope to see expanded in other parts of the world. Fertilizers. This is not a market that a lot of you probably were expecting to hear about, and I just have 2 slides on it, but I think it is a key market segment that's happening here in India as well as the rest of the world. An 800% increase in the zinc fertilizer market sounds hard to believe, but when we started the Zinc Nutrient Initiative, the baseline for the zinc going into fertilizers was only around 40,000 tons of zinc. Over the past, let's call it 9 years, thanks to the efforts of Dr. Das here in India, our efforts in China, in Brazil, in Mexico, the United States, and elsewhere, that market has now grown to 375,000 tons of zinc going into fertilizer market. So it now represents about 2% of the overall zinc market in terms of usage. And these statistics come not from IZA, but they actually come from a group called the IHS Market and Markets, which do statistics in this area. So this is, I think, a very exciting new area that's been developing over the last number of years, and we expect this growth to continue for the foreseeable future. If you look at the requirements for zinc here in India and elsewhere, it shows a great opportunity to expand this even further. And along these lines, I'm very proud and pleased to announce, if you have not heard this already, that IZA and the zinc industry has partnered now with World Bank. We actually have a program going on here in India, in Rajasthan. Dr. Das and I are traveling out there tomorrow to visit the site and meet with World Bank, to meet with the farmers that are participating in this program. But why is this important? One reason for World Bank to partner with the International Zinc Association, with the zinc industry, to undertake a program like this, they recognize the importance of food security, they recognize the importance of nutrition security. And by doing this pilot study as proof of principle, I want you to recognize that World Bank invests just under $1 billion annually on agricultural programs. So if we can show success here in India, in Rajasthan, with this effort, World Bank has agreed to help expand this effort into their other areas of focus. And that's in over 75 different countries, and again, with close to $1 billion. So again, add this to the other areas that we were talking about in terms of market potential, and you see a very significant cumulative effect happening here. And I didn't want to spend too much time looking at the different regions, but I did want to talk with one slide about China, because China represents such a major production area for zinc, but also a usage area. So some of the key programs we have going on in China match what's happening here in India with the automotive market. The penetration, as you saw on that slide earlier, in the automotive market in China is around 70%, 65%, something like that. And so there's opportunity to grow that. Not as much as India. I think India actually has the greatest potential for increasing the use of zinc in the automotive market. But there is still more to be done in China. And then the Smart City program. We heard a number of very good talks about this yesterday. And I think this is another opportunity in China to help develop further. My second to last slide just touches on communications. This conference that we're having right now, I think, has been a tremendous success. And that goes to one of the values that IZA brings to the zinc industry and others, is creating networking opportunities like this to hear about the great advances that are being made within the zinc industry, within the markets for technology market development and so forth. And so we have this conference going on, and you can see a number of other conferences that we have organized through the coming next 6 to 8 months. So I would strongly encourage you to work with us, participate, and come to these conferences and learn about the latest advances in zinc. And with that, I just want to summarize my presentation with these 3 bullets. First being that thanks to the efforts and the opportunities here in India with zinc in the galvanized sector, especially for automotive, for thermal spray, for galvanized rebar and so forth, the market potential for zinc is extremely high. We see a lot of initiatives that are happening right now already with success, such as the thermal spray program with the railway system here in India. We see that expanding further. We see opportunities with the automotive market and so forth. So there's no question that we will see an increase in consumption here in India and globally. IZA is working to develop these markets through these activities that you've seen here, plus a number of others that I did not have time to touch on. I'd be happy to talk with you more about that during the breaks and lunch. And then finally, one of the key messages that I think we should all be putting out there, because we have the information and data to back this up, is that zinc is sustainable and it is essential for a modern society. Thank you very much.
Thank you very much, Dr. Green, for apprising us about the global opportunities and the way ahead for zinc galvanizing. Thank you very much. And yes, once again, as we are going ahead with the second day of our 3rd International Galvanizing Conference, we'd like to tell all the participants that we have some exciting giveaways towards the end of the session. We request you to be there with us all throughout the day. Look forward to great learning and deliberations with you all in this journey. Now moving ahead, we'd like to hear from Mr. Rajesh Pais, Head Technology, CRCA and Coated. Mr. Pais is an alumnus of IIT Kharagpur and IIM Calcutta. He has extensive experience in commissioning and operation of contentious galvanizing lines, developing innovative coated steel products for automotive industry for over 20 years. And he has several research publications in international and national journals and conferences, and 5 patents to his credit. Today, Mr. Rajesh will be apprising us on coated steel for automobiles. So requesting Mr. Rajesh to join us here with a round of applause. Let's welcome Mr. Rajesh Pais once again. Sir, please.
Yeah, thank you for such a nice introduction. So today my topic is on coated steel for automobile industry. And I have been working in this area for quite some time. So I am very eager to share some of the things which I have done so far and how it is going to help you as well. So my presentation will cover basically what are the challenges in automotive industry, and about development of advanced high-strength steel, and the issues related to usage of advanced high-strength steel, and how the steel industry is innovating for galvanized advanced high-strength steel applications. So you can see the challenges for automotive industry. Apart from, there are many challenges, but from steel perspective, I think the fuel efficiency versus safety is the most important challenge for automotive industry. Now, what is the solution? You can see the graph, the CO2 emission is more fuel efficient vehicle, and the regulations are asking for more safer vehicle in crash. And the only solution is lightweighting, which is offered by advanced high-strength steel. Now, if you look at the auto industry, what they need from steel, they need a good mechanical property which can help them in forming. What they want is good welding and joining technique, so ease in manufacturing, so as to reduce the cost of vehicle. Of course, styling is an important aspect of automotive or a passenger vehicle, and the environmental impact that we discussed. Now, how do we translate this requirement, what the end consumer is asking for, and how steel industry works to satisfy that requirement? So we start with a concept, and then we design, then the steel making, casting, hot rolling, cold rolling, and then it is galvanized in a continuous galvanizing line. So, and what the car maker is doing with this steel is they are blanking, forming, joining, and painting. Painting is a very important subject for a car. Sorry, now looking at the development in advanced high-strength steel, this is a typical banana curve. So I think in every presentation you will see this curve, which is basically total elongation versus tensile strength, ultimate tensile strength. So it is obvious that as you go high on strength, you lose on your ductility. But there are areas of improvement like second generation high strength steel and third generation high strength steel. Now second generation high strength steel did not pick up or was not successful because of other issues. These steels were suffering from room temperature embrittlement or delayed embrittlement, which was the main reason for steel industry has rejected that area. Now we are working on third generation high strength steel. Now when you look at the car safety, obviously it is the intrusion where high strength works, but when you look at the front crash, where you need an steel which can absorb lot of energy, and this is what translates into a tougher steel, and which is the most difficult steel to manufacture. Now looking into the steel, can I get the pointer? Yeah, looking into the steel. Now steel strength can be easily increased. Let's say from typical 300 megapascal level to maybe around 1200 megapascal, just by tweaking the microstructure as well as the phases present in the steel. Now this so looking at the development here, I would like you to give attention on how the microstructure is being modified to achieve the strength level. This CP is a complex phase steel. Dual phase is basically ferrite and martensite. So this is a well accepted steel by an auto industry. But other steels like complex steels and martensitic steels, these are into the research stage, or they are just going to be adopted in a car vehicle. Now this slide is again talking about the same thing of development of high strength steel, but here this graph is basically showing how the uncoated or cold rolled steel and this galvanized steel is moving together or reaching at the same level. So you can see the trend. The earlier speaker talked about 80% of auto body in coated steel. So this is going to happen in India as well. Now this steel is the future steel, which is being basically propagated or invented by Professor John Spear, quenching and partitioning. And this steel is not in a research stage. It is already translated into a commercial manufacturing grade. This steel is very important from the point of view of it has a potential to replace hot forming grades like what the Arcelor makes, a hot forming grade. So in hot forming, what happens, you start with the lower strength and you bring that steel to the austenizing temperature and form it and quench it rapidly. And this patent is being borne by ArcelorMittal. So nobody in the world can use this steel for hot forming application. Now this steel, when you look at quenching and partitioning steel, this can go up to 1200 megapascal strength level. At the same time, it can be easily formable. Of course, not like a softer steel, but you can form this steel and make an auto structural component. So the important step here is you start your carbon in the steel, and when you are cooling in such a way that you get some martensite as well as retained austenite. And there is another process of again heating and raising the temperature. Now this raising the temperature, what is happening there is basically partitioning is happening in carbon is moving to the austenite region because austenite is not stable at room temperature. And this is where the main concept lies, that how you can make the austenite how you can improve the stability of austenite at room temperature and thereby giving this steel good formability. Now when we look at the outer skin, typically this is a very soft material because you need a styling, you need a very good shape, aerodynamic shape. Now the movement is, people are going for dual phase steel. This is very strong steel. It has a ultimate tensile strength up to 500 megapascal. Typically, currently 300 megapascal steel is used or 350 megapascal steel is used in body panel. But you can see the potential, it can bring down the weight of the vehicle as well as it can make it safer. This is the most complex part of a auto body, which is called as the outer panel. And here you can see earlier the soft steel was used, that is interstitial free steel, and then the movement happened to bake hardening steel. But now people are using high strength IF, which is basically a rephosphorized steel, which gives you very high strength, at the same time improved drawability. So you can see this is IFHS steel, which is around 390 megapascal UTS and 180 megapascal of YS. But drawability is improved. Now, coming back to the galvanizing process as such, so I think this is a typical galvanizing line. Now, when we look at the different coating system, what are available, the first one is obviously the pure zinc, which we are using day in and day out. GA is a preferred material for auto body because of its improved weldability as well as corrosion resistance. Galvalume, these are the coatings which are used in other industry, not in automobile industry. There is a correction here. This is not GA, but this is the MagiZinc or zinc aluminum magnesium coating, which is going to replace the GI because of the improved corrosion resistance here. AluC is the coating which is basically used for hot forming application as well as high temperature resistant application. Because of this, it can work on a high temperature areas, whereas zinc is normally restricted below 200 degrees centigrade application. Now, looking at the coating process, here I will just focus on the most important area, that is this inhibition layer. When you dip your steel into the zinc bath, because of the aluminum presence of aluminum in the bath, you start getting the inhibition layer. And the whole concept of making a good galvanized steel, it lies in how do you control your inhibition layer. This layer is very, very thin, maybe around 600 to 700 nanometers, but this is very rich in aluminum. It is Fe2Al5, and this control is very, very important in terms of adhesion property or in terms of anti-powdering property in the steel. Now, I will skip this slide. The next product, which is GA or galvanized material, normal steel which is annealed again, and your coating microstructure, instead of pure zinc, it is transferred into a zinc iron alloy, and iron content is normally around 10 to 12%. Now, this is a process by which you make that coating very good for welding application, and that is why it is being preferred by automakers. Now, what is the steel industry is doing for cutting the cost? Like you see, when you want to make a higher strength steel, you need to add a lot of alloying elements. All these alloying elements are very costly, and it makes the steel costlier. But here we are trying to get the advantage of rate of cooling, because if you increase the rate of cooling, you can reduce your alloying elements, and thus you can reduce the cost. Now, this is a technology where steel industry is moving to use around 50% of hydrogen in cooling section to improve rapid cooling for getting the same strength level. Now, when this steel is put into the vehicle, when you are making steel thinner, you lose on the stiffness of the material. Even though you can guarantee the strength loading thing, but it cannot withstand the rigidity of the vehicle. These are some of the issues when it comes to use of galvanized material in auto industry. So you can see the level of difficulty is increasing as you are making your material hard and galvanized. So this slide captures the major issues what an car manufacturer faces when they use high strength and coated steel, The flatness control is an issue because of the very high strength and rapid cooling and addition or achievement of different phases in the same steel. And all these phases are having different coefficient of expansion, and that is why you struggle to control this flatness of the steel. As you increase the yield strength of the material, obviously spring back is going to come, because spring back is a phenomena which is related to yield strength and thickness. When you move to high strength material, you are more prone to hydrogen embrittlement as well as liquid metal embrittlement when you are using zinc at high temperature or like hot forming application. Another problem with high strength steel manufacturing and galvanizing, when you add lots of alloy into your steel, all these alloys are trying to move or segregate toward the surface of the steel because of its higher tendency or propensity to migrate towards the surface. And these oxides are not wettable, means you cannot coat. Like this is a normal galvanizing process. Your steel is here, your steel will react with zinc, or zinc is going into the steel and it is making an inhibition layer here. But the moment there is oxide, maybe a oxide formed by manganese or silicon, that will interfere in making the inhibition layer, and that is how you start getting the issues of uncoated area in high strength galvanizing. Now this is a new facility. Only a few universities or few steel makers have this facility of hot dip galvanizing simulator, HDPS. Now this facility is being installed in NML, National Metallurgical Laboratory at Jamshedpur. And this is with in support with Ministry of Steel, Tata Steel and NML. So my colleagues are sitting here. I think we have shared the leaflet on this facility. So this is a unique research area where we can experiment on high strength steel coatability issues, and this is helping us to develop high strength indigenous steel in India. Just, I will skip this slide because this slide basically summarizes what are the issues and how the steel manufacturers are addressing all these issues. Like weldability of steel is a problem, and when we continuously process strips in our mills, they need to be welded continuously. So this welding with high strength or high alloyed material is a problem, and the solution for this is to use of laser welding technology, which is basically you can get rid of, you don't have to count your carbon equivalent, you can just go and weld that steel with laser welder. Other thing we discussed on this, I think the important technique here is the bath management. Zinc bath management is a very critical area for continuous galvanizing, and Tata Steel has developed software, real-time process modeling, which can help in controlling the aluminum layer in the bath and as well as in the coating, that is the inhibition layer, so as to cater to automotive industry. Now this section is talking about the BS6 regulation and what is the impact. Now with BS6, two-wheeler industry is facing a major problem because BS6 is asking for emission controls which cannot be guaranteed by a typical carburetor controlled ignition system. Now they have to move to a fuel injection system. The moment the two-wheeler industry is moving for a fuel injection system, there are chances of blockage or choking of these injection systems because of the rust which is coming from the fuel tank. Now, this is a very, very important subject because the moment you start using fuel injection system, and if rust is going there and choking, then you will see most of the motorbikes are just stalling after few kilometers. So Tata Steel has developed a solution. Typically overseas or the global market is using electrogalvanized material, that is zinc nickel electrogalvanized steel for fuel tank application. But in India, electrogalvanizing has not taken place because of the power cost. So Tata Steel has developed a secondary coating which can basically prevent corrosion in fuel media. And this fuel, as per BS6 regulation, is going to have minimum 20% of ethanol. And our government is trying to increase the ethanol addition. The future is that we can move up to 50% or even up to 100% like Mexico or other countries who are operating with E100 fuel. As you add ethanol into the fuel, it becomes more corrosive, and that is how steel industry need to provide solution for increasing level of ethanol in the fuel tank, in the fuel. This is another example of innovation, which is we offered for our Tata Motors facility. Earlier, this is again the same thing, but earlier when this fuel tank was made from aluC material, and this aluminum silicon material, there is a problem of welding, which Tata Motors could not resolve. And that is how they asked our help, and we offered a material in GA material, galvanized material with secondary coating, which can replace the aluminum silicon fuel tank. And this has been working for last 5 years with these trucks. Now, we have seen there are many problems in using the high-strength steel. Now, steel industry is developing new solution, how to improve the formability of the steel. So, there is a new layer which is added on the top of the steel, which enhances the lubrication properties, that is the coefficient of friction. And you can see here the draw depth is increasing just because of the addition of thin coating, which is just 1 micron thick. So now to summarize my presentation, this coated steel obviously will remain as a preferred material, and obviously we are talking about how we can move to a 65 or 70% usage of zinc in auto industry. Advanced high-strength steel will obviously have to move in higher strength level so as to reduce the weight of the car as well as make it safe. And there are certainly, when you make steel, the car industry also need to improve how they can use this material in their facility. And you know that both steel as well as automotive industry, both are highly capital intensive. And it is very difficult to install a facility. By the time you install the facility, then the research is moving to a next level. So that is again a problem for this development. Thank you.
Thank you very much, sir. And we'd like to share with all our delegates that we will be having question answers towards the end of the session. Once we come towards the conclusion of the session, we'll open the floor for few reflections, few insights and queries from your side. Nonetheless, moving ahead with the agenda and looking into the aspect of trends and developments in galvanized car bodies and automotive zinc coatings in India. For the same, we are delighted to have amongst us Shri G. Vijay Sankarji, Principal Engineer, Mahindra and Mahindra, working as the Head of Metallurgy Department in Materials Technology Center of Excellence at Mahindra Research Valley, Chennai. Shri Sankar has 22 years of experience in the automotive industry. He is leading a team of 12 metallurgists and responsible for material selection and specification, process specification, benchmarking, and supports new product developments for auto and farm businesses. He is responsible for concern resolution, failure analysis, cost issues, amongst others. With a round of applause, let's welcome Shri G. Vijay Sankarji. Welcome, sir, and we look forward to learn from you.
So, thank you very much for the wonderful introduction. First of all, I would like to thank International Zinc Association for giving me this wonderful opportunity to talk in front of this elite crowd. So let me start my talk with the inspiration from our beloved chairman. The job of automobile manufacturer is to passionately build something that others love to own. So we are talking about the durability of various, say it as infrastructure, say it as pipelines that are being used in various industries or the cars. So durability is what that we are focusing on, and we will be touching more aspects of durability. So broadly, I would be covering, these are the topics today in next 15 to 20 minutes. So trends in Indian automotive industry, need for galvanized sheets in automotive industry, use of the right specification, and there is an increased area of application of coated sheets, and what are the manufacturing challenges that we have in using coated sheets and the way forward. Okay, so before we get into the actual content of the topic today, so let us have a close look at what is happening in automotive industry. So what are the driving factors which are transforming the auto industry into a future? So the top of the list comes autonomous cars. So artificial intelligence, machine learning, neural networks, these are the buzzwords in automotive industry now. Then comes connected cars. Most of the Indian OEMs are investing heavily here because that's future. Electric vehicles, of course, no need to talk much about it. Everyone is aware about electric vehicle, and China has already grown, and India is a growing market for electric vehicle. Of course, lightweighting of cars, we can never get away from lightweighting of cars because with respect to sustainability, it is very important. Then upcoming crash norms, even a common man, he knows about what is the star rating that I'm going to get when I buy a new car. Then last but not the least, BS6 is a buzzword now. So that is what, these are the 6 major trends that, that is transforming the auto industry to the future, because I would like to touch upon here because all the trends has got a relevance. Probably we will connect at the end of the session. Okay, having said all the trends, what is that an automotive OEM is offering to a common man? So when a common man walks into a dealer or when he wants to buy a car, so what does he look for? So he looks for brand. So for me, brand is quality. Then he looks for price, safety features, of course, performance, of course, the durability, NVH, ride and handle. So these are the parameters people started looking now. Styling, this comes from family members. Fuel economy, people are watchful now. Comfort and space. Then comes your after-sale service, dealer experience, and resale value. So in today's topic, I would be more talking about how OEM is working towards ensuring the quality of the cars, safety, how are we ensuring, and how do we meet our performance requirement, which is a huge demand in our Indian auto industry. So, one way of looking at how OEM works is to look at the warranty. Let us look at the warranty clauses which we offer to a car buyer. So, when I talk about warranty, there are various elements of warranty that we offer. So, I mean, the basic limited warranty, which talks about any manufacturing defects in the material or manufacturing processes, or there are some lot of full system supplier parts like clutches, wheels, batteries. So this all covers comes under basic limited warranty. Powertrain warranty, that is given separately. That's for the engine and drivetrain. Then most importantly, what we need to look at is the corrosion warranty. Again, it has got two elements. It is like your cosmetic corrosion and perforation corrosion. And there are some inclusions which we will not be talking. I mean, of course, any warranty clauses, there will be some inclusions. We need to be careful on that. And how is it given? When I talk about corrosion warranty, how it is given? So it is basically given for all the sheet metal panels which are there in the vehicle, we give corrosion warranty. So in that corrosion warranty, there are two elements. One is for all the sheet metal panels, there are some number of years are given, and for the A-class surfaces, there is additional number of years given. So normally, each OEM gives a different warranty life. That is why I have just put, X here. Okay, now, there are many systems in the vehicle. So today we will be focusing more on BIW, body in white. So when I talked about the safety of the cars, durability of the cars, ride and comfort, everything comes from here. So yesterday we were listening, the steels of, the thickness, say 10 mm, 12 mm, 20 mm, 25 mm. I keep hearing like that. But this, such an important body in white, can you all imagine what will be the thickness range? So the maximum thickness of each sheet panel is maximum up to 2 mm, and it goes down up to 0.6 mm. So the range of sheet metal that is being used is 0.6 to 2 mm. So that is why, the various functional requirements we need to look at very clearly. So if I look at functional requirement, of course, stiffness is one, safety is another one, comfort is another one, and service life. So when I talk about service life, what does it refer? So we need to focus more on the corrosion, because as I talked about, the thickness of the sheet metal panels which are getting used in constructing this BIW is 0.6 to 2 mm. We need to retain the quality of this sheet metal, such a thin sheet metal, to its service life. Okay. Now when I say corrosion, what does it mean? It is basically rusting of the car bodies. So the rust happens on the A-class surfaces. On the outer surfaces, you can see there is a perforation corrosion on the door handles or on the front door bottom side. It also happens inside the engine compartment. It also happens on the underbody, which is the most abused location of the vehicle per se. So this is this is an issue that we need to, every OEM has got an issue to resolve this. Now, what is the approach that we follow? What is the approach that we ensure we follow to ensure this corrosion-free vehicles to the customer? It starts from design stage. Yeah, when a designer sits and he designs, first of all, he looks for any regulation. Then he looks for the warranty targets. Is there any warranty? I mean, for that particular market, what is the warranty that business wanted to give? And application, panel by panel application requirement. And we also look for benchmark because that competition have to be met. Once the car is built, once the design is done, when the car is built, we subject the car to a various validation tests, say proving ground test. So before we launch the car, we do a lot of validation tests and we get the results, I mean, in terms of what are the corrections that we require. We get a lot of insights, we get a lot of inputs from the validation test. The validation test, it happens even on a system level and part level. Apart from these two stages, we also get inputs from our workshops and dealers. So that is what we get the compliance as a customer complaint. We compile all the data and we consolidate it and we take this as a front loading whenever we launch a new vehicle program. Okay, right. Now coming to the implementation stage. Okay, we have planned it well. Now we are going to implement. So when we wanted to implement, what are the options that OEM has got? So they have got various options of doing it so. I mean, what I mean is the corrosion-free cars. So as I said, it starts from design, and we can work on advanced paintings and pre-treatments, better waxing and sealant practices so that we are preventing the water or the moisture going inside the car body. And then comes your use of coated sheets, that is galvanized sheets. And we also work on some alternatives, use of some plastic material and aluminum material. Most of the recent vehicles, if you look at the fuel lid, every day when you go to petrol bunk and when the guy opens the petrol lid and he closes it, that fuel lid has been already converted into plastic. So I mean, I'm just talking about there are some options available and OEM explores that. Okay, when I talk about galvanized sheet, it is, I think we have talked enough about it. It is application of zinc coating on a base metal, which acts as a sacrificial layer. Okay, with respect to automotive perspective, how this galvanized sheets works? Of course, it gives a high corrosion warranty life. And whenever you have a paint chip off problem, we are SUVs, we are into SUV manufacturing. SUVs, we get into off-road. We get a lot of stones coming and hitting on your car panel. The car, it damages the paint. So in the event of stone chip off, the underneath layer, which is zinc, which protects the car from corrosion. And we talked about different styling requirements, and so different styling requirements comes with a very complex sheet metal panels. Those sheet metal panels are very difficult to paint. So most of the time in the painting process, you will end up in the paint reachability is not there. So there we have a simple option of going for galvanized sheet is an excellent option. With respect to the alternate process available, that is your wax treatment and sealants. Coated sheet is definitely cheaper. We can definitely look at it. And enhanced customer perceived quality is another aspect. Okay, now what are the options an OEM has got? I have decided to use coated sheet. So what is that I have got? So there are 4 options. Broadly I can classify into 4 baskets. So hot dip galvanized iron, hot dip galvannealed, and EG coating and alucy coating. Alucy coating is generally meant for very special applications. It is used in a fuel tank. It is used in exhaust pipes, and there are some hot stamping panels are being used where we use alucy coated. Electro-galvanizing, we are not going to talk much about it because there is an increasing trend globally. So we'll be talking more on GI and GA. So when I have a pure zinc on the steel substrate, it's called GI. When I have alloy coating, it's called GA. So you have some, approximately 10% of iron present on the zinc, which is called galvannealed, and you have a thickness limit, thickness or the coating weight limitation for each coating. Now, how do we optimize my specification? So when I wanted to use coated sheet in OEM, so how do I optimize my specification? So there are various factors that is influencing the specification before I finalize on the coated specification. So target life, corrosion target life is one main factor that I need to look at it. Then choice between GI and GA, because corrosion life and GA has got a relevance. Formability, which I'll be talking in few next slides. Formability aspects we need to look into. And we also encounter flaking and powdering, that is an issue. The previous speaker from Tata Steel, he talked more about that. Cost is another factor that I need to look at it, and availability. So even though I want to use some GI sheets for my higher perforation warranty, I may not be, because most of the steel mills are not producing GI on a common grades. Okay, let us look at the application areas, various application areas within BIW. 5 years before or so, when I talk about the outer panel, we used to have only outer panel and other sheet metal panel, we used to have only EDD or bake hardening steel. Now there are a lot of high strength steel that is also being used for your outer panels, and so there is an increased, apart from the skin panel, we also started using it in the inner panels. So there is definitely an increase in the usage of coated sheet. Like, the front doors are being galvanized, both inner and outer panel. Even the reinforcements are being galvanized, run channels are being galvanized. Hood, inner and outer, tailgate, inner and outer, body side outer, fender, even the inner and outer panels are being galvanized. So we keep increasing the usage of coated sheet. Apart from this A-class panels, I talked about various safety requirements which we are working towards meeting the star rating requirements. So this is a picture. Normally we subject the body in white, or as a vehicle we subject the vehicle into frontal crash and side impact crash. So whatever the panels or the components which are coming in the pathway of frontal crash and side impact, we are also converting those panels into coated sheet. So this is leading to an increase in usage of C-pillar, D-pillar, side sill, and long members and floor. So we were not using it. We were using only a uncoated sheet. Now there is an increase in trend. We have started using these panels as a coated sheet. Having said that, what are the challenges that we have in using a coated sheet in automotive industry? So I can basket it into 4 different categories. We have starting from varying substrate, spot weldability, formability, and paintability. So let us look at one by one. We talked about lightweighting. Lightweighting we cannot get away. Lightweighting is, with respect to sustainability, we need to have multi-material concept. So there are different categories of steel that are being used. You have ultra high strength steel, advanced high strength steel, right from mild steel, everything. You have a different kind of steels. If you look at their properties, you have get into details. You have DP steel, you have complex phase steel, and you have trip steels, and you have martensitic steels. And let us look at their mechanical properties. So there is a varying elongation with respect to the strength levels. So it has got a direct influence in formability. Of course, for the lightweighting, you need high strength steel, but at the same time, I should be able to form it as a panel. So there is I keep changing my grades, I keep optimizing my design using these steels. And accordingly, I would request the steel mills to gear up to coat all these steels. So that's a challenge. We need to work with the steel mills. Let's talk about formability. Sheet metal formability can be well understood by N values and R bar values and FLD. FLD is nothing but forming limit diagram. So this is a typical forming limit diagram. So when I do when I do forming of sheet metals or when I do a stretching, the green line, any strain which is below the green line, I will not have a problem in terms of necking or breaking. So when from coated to uncoated, when I switch, definitely the green line is coming down. So the formability window is getting restricted. That's what I would like to say. So we have not left there. We have studied what is causing that. Typically when I use galvanized, galvannealed sheets, what is it is contributing? So there are 3 parameters which is contributing. So we got into the details, the iron percentage, coating weight, and microstructure morphology. So instead of having a plain zinc coating, when you have a galvannealed coat, there is a varying hardness and varying microstructure. So this leads to the coating becomes harder, and when you do a forming, you will have issue in forming. So ultimately, we are aiming we need a corrosion resistance. We need to strike a balance. We need to have a corrosion resistance as well as with adequate formability and not having a powdering, flaking during forming process. So this is a challenge that we had to come over. Let us look at welding, coated sheets welding. Why welding is so important? I talked about the very thin material that is being used in BAW. When it is assembled, we also subject the BAW into a very critical bending stiffness requirement and torsional stiffness requirement. So this has got a direct influence for the comfort of the rider. So if it is not done properly, you keep hearing noises and you feel that car is becoming old. So that is why this bending stiffness and torsional stiffness is very important. And how it is connected to usage of coated sheet now, because when you weld it, this is a typical weldment you have, and welding happens on the surface. So there is zinc layer is there between 2 sheet metal panels which need to be handled very carefully. And we have a very stringent test requirements to evaluate these spot welds, and we also evaluate how this weld fails. So the different panels fail differently, and we are evaluating very critically how this is failing. Now, this is a typical welding spot weld cycle. So you have, since there is a heating and cooling cycle, obviously when there is a heating, instead of having a plain sheet, if you have a coated sheet, you will have the electrode life comes down, so it requires electrode dressing frequency need to be established, which we have done. And as compared to bare metal, it requires a higher current. Again, there is a welding process optimization is required. And once that weld nugget dia is established, there is no difference between coated sheet and uncoated sheets in terms of weld strength. So I talked about why spot welding is important and how did we overcome this. Paintability, let's talk about paintability of coated sheet. Obviously, painting adhesion is good. So you have a improved customer perceived quality. And sometimes we also use chromate free coating to ensure lubrication, which is definitely being used in our painting process. And of course, it improves the durability. So when we had 2 choices of GA and galvannealed and galvanized iron, now this chart will give us the learnings, what we have learned so far using this coated sheet. So in terms of perforation corrosion, there is no difference between GA and GA. Formability, obviously you have a zinc layer there on the top which is ductile, so it acts as a lubricant. The formability is good. Weldability wise, we have issue in GA. Paintability wise, obviously GA is better. So these are some guideline chart that we could establish from R&D, and we are given it to the plant. Okay, now let's come to, with all the difficulties, so where are we on using coated sheet in car bodies? Still, This is the information I'm sharing because it is little sensitive information that we have got from our benchmarking data, because we do a lot of benchmarking. We buy cars and we completely dismantle, we see what type of coatings are there, and we have developed in-house capability to identify which coating it is. So, of course, North American and Europe market, they have already started using minimum 70 to 90%. So when I talk about 70%, it is 70% of the BIW. So typically vehicle is weighing 1,400 kg of SUV. The weight of the BIW alone is 450 kg. So roughly 300 to 350 kg of coated steels are being used in Europe market and North American market. And India is still up to upgrade. We at Mahindra, we have experimented on few projects. We have gone up to even 70%. Again, there are, let me go to the next slide, so I'll talk more on there. So Korean and Japanese market, they are somewhere in between. So they are not completely switched over, but they are in between. They are slowly graduating and they are very rational. So this is my summary slide, usage of coated sheet in automotive industry. So what are the drivers? Drivers, of course, competition is driving us. Durability is our, as you know, I take it from my chairman. So durability is what I am looking for. Customer perceived quality improves. More and more application I am pushing. Of course, I have to appreciate the domestic steel mills. Everyone is geared up to support us. And where do we need focus? So there are a lot of lack of regulations. So it becomes a business decision. Still, regulations are not very clear to use coated sheet. And last but not the least, India is a price-sensitive market. So, we need to, we have to closely work with steel mills for optimizing the coated sheet price, either by optimizing the steel with the existing coating thickness, what is the additional performance that I can get, or how do we standardize the steels and get cheaper steels in coated condition. So this is all I have to say today. Thank you very much.
Thank you very much, sir. Once again, a round of applause to express our thanks to sir. Thank you. And now with this, we move towards a very interesting panel discussion where we will be looking into galvanizing for automobile bodies. So for the same, and we'll be having industry voices, media representative and consultants view, a very exciting session where that is the panel discussion. Let's go ahead with the panel discussion as we invite on the panelists. Requesting Rajesh Pai, sir, please join us once again. Head Technology, CRCA and Coated Tata Steel Limited. Rajesh sir, welcome back once again on stage. जोरदार तालियों के साथ सर का हम स्वागत करेंगे. Welcome sir. I call on Shri G. Vijay Shankar sir with us back on stage, our principal engineer, Mahindra & Mahindra. Vijay sir, please, once again. I know after that hectic deliberation, we are delighted to have amongst us most respected Professor Anand Khanna sir, Professor IIT Bombay. Requesting Anand sir, please join us. Namaskar sir. With a round of applause, let's welcome sir. Our next panelist, Mr. Ken D'Souza, Consultant, International Zinc Association. Ken sir, welcome. And this very esteemed panel will be having a very esteemed moderator too. We are delighted to have amongst us Mr. Dipanshu Dev Sarma, Editor-in-Chief Auto Tech Magazine. Requesting Dipanshu sir. Sir, welcome. Round of applause to welcome our moderator. So here we are, esteemed audience, with the presence of our moderator, Dipanshu sir, our panelists, Mr. Rajesh Pai, Shri G. Vijay Shankar sir, Professor Anand Khanna sir, Ken D'Souza sir. We will be looking into what lies ahead for the galvanizing aspect for automobile bodies. So we have industry voices, media correspondents, and the consultants all getting together to present to us this panel discussion. With this, I'll request our moderator, Mr. Dipanshu Dev Sarma sir. Sir, we hand it over to you for the panel discussion.
Thank you very much. Truly appreciate it. It's an absolute honor to be here and listen to wonderful presentations. Although I did not manage to come here yesterday, I'm sure it would have been even far more interesting and educative. However, I understand we have about 35 minutes for this discussion. So it's very clear the need for the auto industry to get into galvanized steel, right? So let me start. We have the subject for the discussion today, the roadmap. How do we create a roadmap towards achieving the global average of 70% galvanized auto body in the country? The current state, of course, is far low. We've had different figures actually. Some studies talk about the content of galvanized steel in Indian cars today at about 30%. We've had a previous speaker talking about that level being at about 17%. So whatever that figure is, it is very clear that we are far lower compared to what the global average is. Whereas at the same time, vehicles that are made for exports, for the export market, have a far higher galvanized steel content. So let me start with you, Mr. D'Souza. I'll come this way. Your first thoughts on the subject before I get into specific questions. And before that, I'd also like to keep at least about 5 to 7 minutes towards the end of the discussion for the audience to get engaged with our panelists here. So do follow the discussions and jot down your questions, and we will come back to you a little later. Mr. D'Souza, your thoughts.
Well, thank you, Mr. Moderator. I appreciate the opportunity to share my experience with the introduction of coated steels in automobiles. So when I moved to Canada, I'm an expatriate Indian, as you can tell, but I moved to Canada 40-odd years ago, and I was involved with a steel company called Dofasco, which is now ArcelorMittal, and we were challenged by the car companies to come up with a solution to some severe rusting problems that was plaguing all the car models. So at that time, there was a gentleman called, I don't know if you remember, Mr. Ralph Nader. He was a consumer activist, and I think at some point also ran for the president of the US. But there was a class action lawsuit launched by Ralph Nader and a group of other people. And so the car companies had to, in fact, respond with a solution to the problem that was, in some instances, killing people because there were perforations after just 2 or 3 years in service. Long story short is that as steel suppliers, we came up with the only way that we could provide protection of the steel and the structural integrity of the steel was to put some zinc on it. We tried many other solutions, but that didn't work, but zinc did very effectively. So then the question became, what level of zinc do we apply? And so as a steel guy, you tend to be more conservative, so we started off with 70 grams per side, and that's how we started. And over time, so I was involved in the early 80s with introducing galvanized in car companies, and I gave you a little bit of the history. So I don't want to steal a lot of time. We don't have that situation in India, but perhaps we need either to find a consumer activist, if we want to model it along what happened in North America, or we have to get some kind of regulation in that regard. So with that, I'll let somebody else have a comment.
Sure. Thank you, Mr. D'Souza. Dr. Khanna, your initial thoughts on the subject.
Thank you very much for giving this opportunity to involve a R&D organization to discuss about a very important issue. If you all remember, before 1990s, when we used to buy Fiats and Ambassadors, we used to see within 6 months, your bonnet, your car bottom, you should have a layer of brown layer. And it was within 6 to 8 months, depending upon where you are. Then in 90s, when Maruti came and it established and it created a totally new culture in the country where we used to have the electro pre-coated steels, the things changed very much. And then around 2011, people like Ken, who had done this experience in Canada, he, along with Hindustan Zinc and International Zinc, they approached IIT Bombay and focused this problem, and they said that the way it should be done is that some study has to be carried out by an important institution like IIT Bombay to find out what is the situation in India. And that is how the work started, and we